Hey, welcome back. This is part 2 of our little instructional on Arduino displays. Again, we have the same 4 common display types here. We've got the 1.3 inch OLED with the SPI interface. We have the Nokia 5110, also SPI interface. We have the 16 by 2 LCD screen. And we have a 0.96 OLED with an I2C interface. What we're going to focus on today is this one here. This again is the 1.3 inch with the SPI interface. So we've got our pins VCC and ground, then we have not connected. We have data in, clock, chip select, data command, and reset. And they're all hooked up to these various pins on the Arduino. Not going to go over it here simply because I show you in the code exactly what it is. You can plug it in right there. And I've also got the DS3231 real-time clock plugged in because we're just going to use it to get data from it for this little experiment here. Now, the techniques I'm going to show you are going to work on all of these displays except this one, because this is not a graphical display. So we can just make that one go away, and it will work for these 3 types of displays. And what we're going to do is we're going to create a custom graphic and display it on the screen. It's not that hard. So stay with me and I'll show you how it's done. Alright guys, here's the code for the custom bitmap on an OLED with the real-time clock. So we start out with our libraries, and then we do our defines, and then we have the Adafruit display setup and the clock setup. We have some variables for the clock. Then we have our custom bitmap. We'll come back to that. We have our setup. We start the I2C interface. We start the serial interface. We start the display. Then we show it's in the buffer. Wait 2 seconds. Clear the buffer. Then we come down here and we do the stuff to get the information for the clock. Now, starting right here, is where we're going to start actually outputting this. And this will work, this type of code, this exact syntax will work with all of those displays except for the LCD, because these are all based off of very similar libraries. So the first thing we do is we set our text size that we want. In this case, I'm using 2. Generally, I think you'd want to use the largest text size that will display what you want on the screen. Just makes it easier to see, right? And then we say display set text color to white. Now, if you want inverse, you could set this to black, comma white. Okay? It defaults, if whatever you put here in the foreground, it defaults to a black background, but you can switch them around by giving it the white background. But we're just going to stick with the white for this. And then we set our cursor positioning. The command, of course, is display set cursor, exposition, Y position. This particular display we're using is 128 wide by 64 high. So in the upper left corner we have 0, 0. In the lower right corner we have 128, 64. Then we do a display.print command for the hour. Now the display.print command prints on the line, and it does not give you a return. It doesn't drop down to the next line. And then this comma .dec here says to show that variable in decimal format. Then we say display.print, and I don't know why those were in single quotes. They should be in double quotes. Perhaps I shouldn't drink so much when I'm coding. Anyway, you notice that the variables are printed without quotes. Characters are printed with quotes. So there's our separator colon. Then we do another display print. We print the minute variable in decimal form, another separator, and then we do this display.println. What that does is it prints this, whatever's in the parentheses, and then it drops down to the next line. Now, if you're using the standard font here, the one font, I believe it is like 10 pixels high, or 7 pixels high. So if you wanted to just use display print commands, when you wanted to come down to the next line, you could come down here, say this is just a display print, put this in here and say exposition 0 and Y position 8. So that will bring you down to the next line. But to keep our code as smooth and as taking up the least amount of memory as possible, we just use the print line command. Everything is the same down here for the date, except we changed our separator to a slash. And right here is where we're going to draw our bitmap. So this is the command to draw the bitmap. We say display.drawbitmap, and this is the syntax. We start with our X position, our Y position, the name of the bitmap, the X size, the Y size, and the color. And then you can see it right here. We say display draw bitmap starting at X position 96. We have 128 wide. This is 32, so 128 minus 32 is 96. So that butts it up to the right side of the screen. Y position 0, we want to start at the top line. We're going to display my clock, and it's 32 wide by 32 high, and we're going to display it in white. I mean, if you have a multicolor display, you can display it in different colors. So let's go back up here. My clock. Where did it come from? Well, I'm going to show you. My clock is a graphic that I created in Photoshop that looks like this. So to get it into this position, we are going to use a little program called LCD Assistant, and I link to it down below. Okay? So here we go, LCD Assistant. So we say File, Load Image, and the image we're going to do is the clock. There you see it. And it needs to be horizontal. Okay? We don't need to include the size. Don't mess with this. It needs to be little endiness. 8 pixels per byte. You can call it whatever you want. We say save output. Put it on the desktop. And we'll call it clock. Well, actually, we'll call it the same thing as we did before. My clock 32. Just so I know it's my clock and it's 32 pixels wide. Alright. So now it's on the desktop and it looks like this. So we just copy this and we paste it in here. Now here's the one thing. I'm sending it to the eeprom. So constant unsigned character progmem, so we send it to the eeprom. And then the word, the name, myclock32. And these are all the hexadecimal bits for it. Pretty simple. Then it displays it right here when we say display.drawbitmap and the name of it. Bang, right there. Then we have the temperature. And that's it. Let's go take a look. Alrighty, we have everything hooked up. Our code has been sent to the Arduino. Let's power her up and take a look. So there we have our time. We have the date. We have the temperature. And we have our custom graphic that we created. Pretty cool. Just remember how that display.drawbitmap command works. And you can put any size display, that will fit and that will fit in the memory anywhere on the screen by specifying the XY start positions, the XY size positions, the color, and the name of the file. If you like this, please give me a thumbs up, comment, share it. And if you haven't subscribed yet, I'll forgive you.